Let's talk about the architecture of Spark streaming just a little bit. It builds on the architecture of Spark itself, so all this should look very familiar if you've seen the previous material on Spark architecture, but let's have a look at the diagram and see what's different. Just like in regular Spark, we have a client that has a driver, and that's the program that's actually got our Spark streaming application in it. Just like Spark, after all, this is Spark. We have a master node and we have worker nodes. Those workers have executors that have some cache and tasks running in them, just like they would in conventional Spark. What we add is, of course, the stream source. There is stream data coming in. That's some source out in the world. Again, it's Twitter, it's Kafka, it's whatever we get data from, and that input stream comes in to a receiver. Now that receiver is just a task. It's a long-running task that will run for the duration of the Spark streaming application. It will always be responsible for receiving the data from the stream source. And again, whether it does that by having data pushed to it on a socket, or it goes out somewhere and reads from some resource, totally depends on the details of the receiver. That's not something that we can determine a priori just from the architecture diagram. That can work either way. Also, notice in the Spark client, the driver has not just a Spark context, but a Spark streaming context. And that streaming context is now the object that we're going to be programming as we build our Spark application. What exactly is a data stream source? Well, let me give you some examples and some categories that they break down into. You've got the basic sources, which are file systems and sockets and Akka actors. Then the more advanced sources that have some kind of protocol to deal with. Like if it's a Twitter source, there is an actual Twitter API that receiver is going to have to implement. If it's Kafka, we're going to have to be speaking the Kafka binary protocol from that receiver to get those messages in. And of course, there are APIs we can implement to make our own custom receivers. If you have your own sources of events, if you're, say, an Internet of Things company and your devices have their own API out there on the web, then you can implement that API in the receiver and bring that data into Spark streaming yourself. Now, receivers can be either reliable or unreliable. A reliable receiver will acknowledge data that has been received. So if the data source is able to receive an acknowledgement and resend data that hasn't been acknowledged, then a reliable receiver will participate in that protocol. It'll send the acknowledgement after it's received data and replicated it. An unreliable receiver, of course, will still be replicating, but doesn't have the capability of sending an acknowledgement when data comes in. Which one of these you use depends on whether you need to enforce reliability, and of course, whether the data source can uphold its end of the bargain, whether it's able to do retransmission and it's able to process acknowledgements itself.